Hey student, welcome back to lecture series on Z transform and inverse Z transform. So for more similar videos, you can go and check here in my I button. You will get the entire playlist, or as well you can check in my description box, guys. Okay, so you will get the complete lecture series based on the Z transform, inverse Z transform, Fourier sine, cosine, and their inverse transform, and first unit, which is a linear differential equation with a constant coefficient. You can check them out from my playlist. Okay, so in my today's video I'm gonna explain to you all for finding the inverse Z transform, which are the method available for finding the inverse of a Z transform, and then we're gonna apply this method for some of the examples. Okay, so I will clear your concept over there. Okay, so let's get start our today's lecture. I'm gonna explain to you all first of all what are the actual method for finding the inverse of a Z transform. Okay, so within all the method we have one very much important method that you all have learned in your previous classes, so in your 12th standard as well. Okay, so let's get dive into our today's lecture. I'm going to explain to you all the methods. Okay, yes, methods for finding inverse Z transform. Let me write here methods for finding inverse Z transform. Inverse Z transform. Okay, so we go for finding methods. Okay, methods for finding, which are the method available here. Okay, so now see that there are three methods that can be useful for finding the Z transform. Okay, yes, so see that first method actually as we use everywhere, like a general method: apply formula, put the value, get the answer. This is the general method. Okay, that is applicable everywhere in mathematics. Okay, any method can be extended from the general method. Okay, so first method we need to know direct method. Okay, what is the direct method? Apply the formula, put the value, get the answer. Okay, this one is the direct method. Okay, this one is the first method. Okay, direct method it says that directly by applying the formula you will get the answer. Okay, yes, but the second method, which is the most important here, okay, which is the most important here, which is the partial fraction method, which is partial fraction method. This one is a partial fraction method. Actually, what is partial fraction method? Already you learn, guys, in your 12th standard, solving of integration by partial fraction. Solving of integration by using partial fraction. Okay, you all already familiar with this. This is the very much important here. This one is the very much important. You will get the definitely question based on the partial fraction method. Okay, so you must have to be very much careful about it here, partial fraction method. Okay, so we're gonna apply here partial fraction method and then go for the finding inverse Z transform. Okay, yes, mostly we solve the question based on this partial fraction method only. Okay, yes, and a third method we have here, inversion integral formula. Third one is the inversion integral formula. Okay, inversion integral formula. Now see that these three methods are we do have here. I will explain this method, and right now I'm not going to explain. If I'm going to explain, guys, it will be very difficult for you all to understand. Okay, so I'm going to explain this method while we are solving the examples. Okay, yes, so let's get to solve some of the example. Okay, general direct method we don't need to go for it. Okay, you can directly put the value. That direct method already we learn in a Z transform also. Everywhere put the value, you will get the answer. Okay, so we start with the partial fraction method. Okay, we go for solving example using partial fraction method. let's go for solving some of the example using partial fraction method. Okay, so I'll explain to you all one of the example using partial fraction method. Okay, guys, I feel that before solving some of the example, I most of the student, they are still confused about the partial fraction. So feel that I how to explain partial fraction before solving these our examples. Now see that, guys, our target, our main aim of our channel is that to clear your concepts. Okay, so just to running it is not that effective, so need to understand the concept properly. Okay, so here you can see I taken here partial fraction method. Okay, integration by partial fraction, that one we are going to apply in our example. Okay, yeah, so if you want, you can take the screenshot for this entire photo. Okay, so you will get the method for partial fraction over here. Okay, yes, so if you have the polynomial in terms of f of x upon g of x, okay, like integration upon f of x upon g of x. Okay, so in such a case we apply, these are the results, we apply these results for finding the partial fraction for integration. Okay, yes, so whenever we have cx plus d upon a x minus b and a and b not equal, okay, then we write it's a partial fraction from a upon x minus a plus b upon x minus b. Okay, this is the way that we write whenever we have denominator as a power 1 only. Okay, next, if you have the partial fraction form of cx plus d upon x minus a square, so we write its partial fraction as a upon x minus a plus b upon x minus a bracket square. Okay, yes, it's a partial fraction, we write this one. Okay, so need to remember, guys, it's very much important. Cx plus d upon x minus a cube, we write a upon x minus a plus b upon x minus a square plus c upon x minus a cube. Okay, if power 4 is there, then we upon write plus d upon x minus a raised to 4. Okay, so that way you have to understand how can we generalize these formulas. Okay, like similarly, cx square plus dx plus c upon x minus a, x minus b, x minus c can be written as a upon x minus a, b upon x minus b, c upon x minus c. Okay, yes, so as we have denominator to the power 1 now, that's why we are taking it 1. Okay, it's way easier, guys, not a difficult. Okay, fifth one we can write first denominator square and second denominator with power 1. So we write a upon x minus a plus b upon x minus a square. Okay, like we have done it here. Okay, a upon x a plus b upon x minus a square and third term is the power 1, so we write a c upon x minus b. Okay, yes, and similarly we can write a upon x minus a plus bx plus c upon x square minus x square plus bx plus c. Okay, so these are the actually important values that we are going to use for the partial fraction. Okay, not all important. Okay, there are some first one, second one, okay, third one. These first three are important here, very much important here for finding the z transform by using partial fraction. Okay, yes, so I'm going to apply this one here for finding the partial fraction, that is here for our today's lecture. I hope you all have understood partial fraction method. Okay, it's not that difficult, guys, it is way easier. So if you want, you can note this down, partial fraction method, it is way easier to understand. Okay, so in my next lecture I'm gonna explain to you all some of the example which completely based on the partial fraction method. Okay, so I hope you all have understood everything here. Okay, even after, if you have anything doubt, difficulty, guys, let me know in my comment section. And if you want to see the method, partial fraction method in detail, let me know, guys, in comment section. I will come up with a similar video. So thank you everyone, thank you for my today's lecture.